In this coordinate proof example, we're given a trapezoid OCBA and we're told that we have the midsegment PQ. We need to find a whole bunch of information based on that. So the midsegment we know is always going to be at the midpoints of the sides that they touch. So the midpoint of CO and the midpoint of BA. Questions here say find the slope of BA. So slope is always rise over run. So let's do the difference of our y's, c and 0. So c minus 0 is c on top. Let's write it out. C minus 0. And then we have b minus a. So c minus 0, b minus a. And then we know c minus 0 is just c. So b minus a, c over b minus a is our slope. Slope of CO, same idea. We're going to take our c minus our 0, our y's first, and then our d minus our 0, our x is second, and that's going to come out to c over d. Now what does this prove? The slope of BA and the slope of CO are not the same. So the only thing we know right here is that they are different, which means that they are not parallel. So we're pretty confident, based on the information we have here, that those lines are not parallel. Clean up our picture. And now we want to find the length of CB. Distance formula says let's find how far apart our x's are and how far apart our y's are. So our x's would be d minus b apart. D minus b apart. Let me square that. And then our y's are c minus c apart. C minus c apart. Well, we know what that's going to be. That's going to be 0. So that's going to actually go away. And in fact, if that goes away, because that's 0, the square root of something squared also cancels itself out. It's kind of like the examples we were doing earlier. And we're just left with d minus b as our length of CB. And let's do the same thing for the length of OA. Let's find the distance between our x's, a minus 0, square that. Distance between our y's, 0 minus 0, square that, add them together, square root it all. Well, again, 0 minus 0, that's going to be 0, so that goes away. And the square root of something squared is going to cancel out. And in fact, a minus 0 even simplifies. We just get a. So our length of QA is just a. The midpoint P, the midpoint of CO, finding that coordinate. Midpoint we know is just going to be an average of our x's and then an average of our y's. So d plus 0 divided by 2, which would just be d divided by 2. That's our x-coordinate of our midpoint, so half of d. And then the average of our y's, the average of c and 0. C plus 0 is c, divide that by 2, c over 2. And our midpoint, remember, midpoint is always a coordinate, so it's got an x comma y. Let's do Q now. We have A and B, and we need to find the average of those two. So let's take A plus B, add them together, divide by 2. And then, same thing with our other part here, C and 0. C plus 0 is C, divided by 2. It's going to be C over 2. So now we have our two midpoints. And the last thing, our complicated step says show that half of the average of the two lengths, so half of the average of this length and this length, and by half of the average I mean half of the sum, so the average of those two lengths is equal to the length of PQ. So we need to first find the length of PQ to prove anything. So we're going to do now distance formula on our midpoints. So let's start with the distance between our x's here. We have a plus b over 2 minus d over 2, so between those two, and we square that, plus distance between our y's. Thankfully this is much simpler. C over 2 minus c over 2. Square that and square root that whole thing. Well, c over 2 minus c over 2 is going to be 0, so that goes away. And then square root of something squared cancels each other out. So we know that our distance here, so PQ distance, is going to be A plus B over 2 minus D over 2. And although I wouldn't recommend trying to pull stuff like this in general, I do know that that is a safe thing because we have like terms in our denominator. They are both halves. We could write this in one big fraction. So that is our distance PQ. Now we have to show that the average of these two is the same as PQ. So let's go off to the side a little bit and let's average those two things. So we have A averaged with D minus B, and when you add them together and divide by 2, you can take an average. So is this the same as this? Yes. Pretty cool. That is a very long, painful proof, but if you make it to the end, it's very gratifying. So that is your coordinate proof.